Okay, gentlemen, we're looking at a short video today on combining like radicals. So we saw this in class a little bit. I'll review one first with just numbers, and then we'll do two with a little bit of progressively more complicated variables. So first, looking at the first one, we just have numbers. So we do our normal tree breakdown from here. Two numbers that multiply to 54. I'm looking for any two numbers. The first two I think about are 9 and 6. The 9 goes down to 3 and 3, and the 6 goes down to 3 and 2. So I've broken that down to prime factors. 3, 3, 3, 2. Circle my group of 3. I have my one leftover 2 with no partner, so he can't come out. I have a 3 that comes out on the outside, and my cube root of 2 that stays in on the inside. So that's my left-hand side simplified. My goal is that hopefully in here I have a cube root of 2 that allows me to combine it with that 3. So let's see. 250, first thing I see is 25 and 10. And then break down the 25 into 5 and 5, and the 10 into 5 and 2. Looks promising because I have 3 5s, and then I have this one green 2. Those 5s come out, the 2 stays in. My radicands match, my indices match. So now I just combine my coefficients, and I get 8, 5 plus 3, and then the cube root of 2 stays the same, and there's my answer there. And that's similar to one we saw in class. At the end of class, we were finishing up one like the one below, so let's do that one a little bit slower, and then we'll look at the last one, which is a little complicated. Okay, with this one, we can kind of see right away, indexes are the same. I have the same radicand with variables. So I have an x to the third, a y, and x to the third to the y. So when I simplify, it should be the same. Let's see. Square root of 8 breaks down into 4 and 2 and 2 and 2, my prime factors. 2 2's come out, 1 2 stays in. For my x to the third, I view that as x to the 3 over 2. So that tells me 1 1/2. 1x is coming out, and 1/2x is staying in. Those are my powers. So I have on the outside a 2 and an x to the first from here. And then what stays in is my square root of 2, this 2. And then I have an x to the 1/2, so that's just an x to the 1/2. Plus my second one. Again, I should have something similar. Let's see, 98. So I'm going to do it by 2 and 49. And when I see that, you can kind of see 49 is a tricky one because that is a perfect square. And we get our 7s that come out, and my 2 that stays in. So far we look good. We both have 2s on the inside. Similar, oh, I forgot the x on the previous one. Sorry, the y rather stays inside. It had nothing else to come out with. Same over here. I'm going to just duplicate this idea right here. This is exactly the same over here. Obviously, my x to the third to the inner square root comes out as a 1 1/2. So that means I have a 7 that comes out, and x to the first that came out. And then I have my square root of 2. 1x stays in. And then I have my y that wasn't able to come out. Had no partner. Okay, so we look here. I have a 2xy, both in a square root, I have a 7x and a 2x. So very nicely, I just combine this to 9x, 2xy, and there's my answer there. Right? Which was slightly predictable for us because we kind of could see besides our number 9 and 98 and 8, they were the same. So it made sense that they were combinable, right? And the only thing we're really messing with is this coefficient, the numbers, the 7 and the 2. Everything else has to match. Every single other thing has to match. Okay, let's look at this last one. Then you'll have some practice problems to do, some simple practice problems. And then your homework, which was assigned yesterday, has some complicated ones in there, but maybe this will help clear it up a little bit. So we see with our square roots, I'm going to do the numbers a little fast because I think we can do that. Square root of 4 I know is a 2. Square root of 16 I know is a 4. And square root of 25 I know is a 5. So I'm going to put those out right away. Okay, now let's look at our numbers. All my indices are 2. Okay. I have stuff inside here stuff that doesn't match inside here, but I have some stuff outside here, and then same outside stuff, inside stuff, but nothing's the same. So I can't do anything with this, but let's see. Maybe I can simplify it a little bit. So here's my x to the 7 over 2, and my y to the 5 over 2. Over 2, because that's my index. This becomes 3.5, and this becomes 2.5. So as we've seen, 3 comes out, 2 comes out for my x and my y. So I have x to the 3rd, y squared. And then I have 1 that stays inside and 1 that stays inside for x and y. X to the 1, y to the 1. Half, 1/2, because my index is 2. So there's my first one simplified. The 4 was very simple, came out as a 2, and then we're just looking at our exponents. Okay, looking at the next one, I'm just going to carry down my plus sign, carry down my x squared, carry down my y squared. My 4 really should go in front of that, so I'll move that in front over here. It should be right in front from the 16. I can just put it right in front there. Now let's see what happens with my variables. So I have x to the 3 over 2 and y to the 1 over 2. Well, the 1 over 2 is going to stay. I can't take anything out there. With the 3 over 2, I get 1.5. So my 1x stays in and 1x comes out. So I have times x to the first. And then inside my radical, I still have an x and I still have a y, both to the first power. There's my x to the first, and there's my y to the first in a radical, because there's the 1/2. So I had my 4 and my x come out. I have x squared y, and then I have this radicand looks the same so far. So 2 of them are good so far. And we'll kind of simplify this in a sec. Let's look at our next one. Again, minus xy. I'll drop that 5 out in front, because that's pretty quick. Now we're looking at my x to the 5 over 2 and my y to the 3 over 2. 5 over 2 becomes 2.5 like we saw before, and 3 over 2 becomes 1.5 like we saw before. So I have an x squared that comes out and a y to the first that comes out, times x squared times y. My 1/2 are the ones that stay in, x to the first, y to the first, index of 2. So now it looks like we have our third radicand. That's the same. Same index, same radicand. Now let's make sure our fronts have x to the third and y squared, because that's when we can combine. So let's make this look a little neater. So 2x cubed y squared, cube root of xy. Okay, that was the first one. I just rewrote that. Plus 4 times x squared times x times y squared. 4x to the third, y to the squared, and then my radical stays the same. So far I still have the same thing, where I have an x to the third and a y squared. X to the third, y squared. Okay, let's look at my next one. Minus 5. Okay, I have an x and x squared. That's an x to the third, and a y, that's y squared. x1, y1. Zooming out so I could see all of this. Okay, radicands the same, which we knew. Very complicated, but at my x to the third, y squared, x to the third, y squared, x to the third, y squared. Just like if I were to have something like, a separate example, right? Just like if I would have something like 2x plus 3y, I can't combine them. But if I have 2xy plus 3xy, I can combine that. Same idea, where I need every single thing to be the same. So now the only thing I'm looking at is 2 plus 4, that's 6, minus 5, that's 1. So what my answer is 1x to the third, y squared, radical xy. All that mess, and your goal is just, it's going to combine. I made it so it can combine. Just make sure you're careful with your simplifying. And there's my final answer. So the only thing I really adjusted was just the 2, the 4, and the 5, once I got everything to match. Okay, so good luck. You have, I think, 4 problems to do, so work on those, and then we'll review it all tomorrow.